Hello and welcome to more exciting Cisco fun. Cisco's Switching and Routing Essentials version 7.2, where today's topic will be Slack, and DHCP version 6. Basically, we're going to cover how do you get an IP address in IPv6. There's a couple of ways to do that, and then how would you set that up on your own Cisco branded equipment, brought to you by Cisco Systems. It is important to have an IPv6 GUA, which is an unfortunate way to say the global unicast address, the GUA. You can do that manually on your favorite Cisco router, IPv6 address. Give it a prefix length. Ta-da! You've configured it by magic. Like manually configuring IP addresses, generally not a thing. While it is a thing that can be done, it is not a thing that is to be done, because it is a pain in the backside. And, gives you a host of potential problems, right? A bunch of places where you can screw up and typo or what have you. So generally speaking, don't do that. So, but if you must, inside of Windows, you pop open this little dialog box in the IPv6 protocols property. You give it an IP address, you give it a /64, give it a default gateway and perhaps a DNS server, and off you go. Check the little box that says validate these, and you're rocking. Somewhat time consuming, somewhat error prone. Probably true. So maybe better to do it automagically. And we have some automagic to do that. If that's happening, what's going to go on is built into the Internet Control Messaging Protocol version 6 is a router advertisement message that will help devices become automatically configured. By default, you get a link local address created by the host when that system comes online, if it's got an Ethernet card in it and IPv6 is configured. If it did not create that IPv6, it is because there was no router that, if it didn't create an IPv6 global unicast address, which in this case, Windows calls an IPv6 address, it won't exist there. This %sign is the zone ID and the scope ID used by the operating system to figure out which link local address, the yellow part here, to associate this interface. And if you're really struggling and having trouble sleeping and want to read the technical specifications by this, sorry, I didn't disappear when I was talking about those. It is all defined in request for comment number 3315. So if you've got a really strange taste in reading materials, it's worth a look. Or if you're ever called upon to write a DHCP v6 client, that'll come in handy. But here's the upshot of how these work. So you have an IPv6 routing device somewhere on your network. It will periodically send out these router advertisements, these ICMP-v6 router advertisements, which kind of try and make it easy for you to set these things up. And you've got a couple of ways you can configure IPv6 to do all this business. There is a stateless methodology where the devices are not tracked, or a stateful methodology where we keep track of the state. So basically, do you or don't you write down the IP addresses of the devices on your network? Both of those ways are using ICMP-v6 router advertisement messages to suggest to the host, to just kind of give it a little guidance. on how it should be configured. And then the host may or may not, based on its feelings that day, decide to accept those. And in the two big categories of dynamic global unicast address assignments, of stateless, where we don't keep track of the IP address, and stateful, you break it down further based on, do you just let that happen by magic? So stateless auto configuration, where it takes care of itself. Do you add in a DHCP server that doesn't care about IP addresses? Don't really think there's a ton of good reasons to do that. Or do you have a stateful DHCP server that does all this router advertisement business and keeps track of, in this case, the IP addresses, and gives, like, the DHCP server assigns all of those parameters like an IPv4 DHCP server does. The stateless version of that, using Slack, which will happen by magic, if you've got a DHCP server, it will provide additional information and information on how to create their own GUIs, globally addressable business. And I can tell, based on the excitement in the air, that you guys are wondering, hey, what kind of router advertisement message flags exist to make all of this magic happen? Well, I'm glad you asked. There are a couple of flags that you can throw in a router advertisement. And if you capture yourself some, like I know everybody is wont to do inside of Wireshark, you would catch yourself some router advertisements, and they would be ICMP v6 messages inside of the IP protocol. The next step on top of that would be that. And then you have these configuration flags that can be set. And those flags can include, but are not limited to, because there's some other stuff we're just not going to talk about, the following flags. You've got your A flag that says this is the address auto configuration. So that tells the client we're doing Slack here. The O flag, which would instead say this is the other configuration. There will be other information available from a DHCP server. So you'll be able to learn some more stuff. Finally, there's the M flag that says, hey, there is a managed address configuration here. There will be a stateful DHCP v6 server involved. It will assign you an IPv6 address. And as those things go down, your client is sitting here, and maybe your client produces a router solicitation message via ICMP v6, like this packet, which just says, hey, I'm a router solicitation. I would like to know about the network. My current address here is this FE80228 address, so my local address. I'm looking to learn how to be part of the big bad internet. So it pops that up there and gets back a router advertisement later on that has that information inside of it. That RA has these various flags set, and by those flags we figure out what's going on. So if we've got that A flag turned on, we're doing Slack, which is a way to make IPv4 networks horrible by having shadow IPv6 networks running on them that nobody knows is there because they don't understand how IPv6 work. So very frequently, penetration testers I work with tell me that you will find a fully functional IPv6 network that the network administrators completely ignore and pretend does not exist because this is going on. So super useful, IPv6 routers. Be careful with this. So if you don't have a DHCP v6 server, which you may not have on your network, Slack will let hosts figure it out for themselves. And due to the vast size of IPv6, this is just fine. Like, we've got infinity addresses functionally. Pick one. So it will go and pick a global unicast address without the services of the server. It just, there's no DHCP server keeping track of this stuff. Every 200 seconds or so, you will get an ICMP v6 router advertisement message that will send out this info to anybody listening so that they can go through and fix it up. Also, as we saw previously, that host computer can provide a router solicitation, which will then hopefully prompt the router to spit out a router advertisement, and you're off and running. So as we looked at in previously with our flags, this can run as Slack only or Slack with a DHCP server inside of it, depending on which way you set it up. So if you are doing this on a Cisco switch, you go in, you pick the port. In this case, gig001 is the port in question. On that, gig001 knows about its link local address. It knows about its GUI and its subnet. And it also responds to the IPv6 all nodes multicast group, so that FF02 address. So those are the ones it is aware of. And then if you want to turn it on so that it can send stuff back and forth, there you go. And it will configure our hosts with Slack, all by magic. So here is showing that command. Turn on IPv6 unicast routing. Off you go. The IPv6 all routers group responds to anything sent to FF02.2. So if you show interface and you've got that rocking, you will now spit out a router advertisement every couple of minutes and listen to stuff looking for that. If your intention is to set up Slack only, in this case, router advertisements, we're going to come up with the A flag ticked that says, hey, you're on your own. Handle this by yourself. That host is going to dynamically create its own interface ID. And then it says, oh, there's no additional information coming. We can ignore the rest of this. Here we've run Windows IP config. We've got our IPv6 address. We've figured out our default gateway, the local address for that bad boy. And we're off and running. Now PC1 has basically set itself up. As we mentioned previously, every 200 seconds or whenever it gets a router solicitation message, it is going to send out info to from that multicast address to all systems. So notice we've got a lot of chit chat happening on FF02 here. Those advertisements just bouncing out every 200 seconds or so. Lets them create their own unique address. So the router solicitation message happens, you get a router advertisement message back. You figure out how to set your IP. If your host is generating that by its little lonesome, it is going to probably randomly generate the IP address. So Slack needs to figure out the 64-bit IPv6 address based on that router advertisement. It figures out the rest of it, usually using a randomly generated address that happens in Windows, and it is happening more and more in the phone operating systems, which are the ones you really care about. There was a not great idea called UI64, which would create a host interface, taking the MAC address, putting FFFE in hexadecimal in the middle of that address. So you take the first 22 bits over here, FFFE, the next 22 bits over there. That's not great for privacy concerns. Your MAC address has the manufacturer of the device and a unique value that is supposed to be unique to the device globally. So you're basically like fingerprinting your phone with the IPv6 address. Let's not do that. So You can go in and modify those. I think you can even tick a box to do, I'm going to please use EUI64 for some reason. But it's the sort of thing that goes on Cisco certification exams. You should be aware of it existing and aware of the fact that it's a bad idea, and you probably don't want to do that if you care at all about privacy. You might not care about privacy on an internal corporate network, though. There is a possibility that is non-zero, but it is similar to the probability of getting bit by a shark whilst being hit by lightning, that you could come up with 2 duplicate 64-bit addresses. 2 to the 64th power, vast number, very, very large number. I'm not going to put it into a calculator, but it's big. It's like the size of the universe, big. It's a big number. So it's possible that you could wind up with the exact same address. So when setting up Slack, you may use duplicate address detection if you're really, really cautious to make sure you've got a unique address. The host would send out a neighbor solicitation that includes at least 24 bits of the 64-bit address. If somebody responds, then wow, buy a lotto ticket, because that's not a probable thing to have happen. If nobody responds, you're not going to have a duplication. If you do get a response, well, then pick another one. And again, go out and buy that. Go buy that ticket. 18 quintillion. This number is big. So calling the chance remote is not accurate. But whatever. The Internet Engineering Task Force says we probably should check. So we probably should check, I guess. If you, like, literally, if you hit 18 quintillion possibility number, get the lotto ticket, because the universe works differently than it does for you than it does for the rest of us. All right, a slightly more sensible way to manage your IPv6 inventory may be to use an actual DHCP v6 server, just because it'd be nice to keep track of the hosts on your network. So using the server does not require you to be using a stateful server, although I don't know why you would bother otherwise, but you would, the way this goes down is you have PC1 here, it pops a router solicitation, it gets an advertisement back from the router, and the router says, oh, by the way, solicitation, gets the advertisement, also says, hey, there's a DHCP v6 server you should go deal with. So it sends the solicit out to that, it gets a advertise back, sends a request, gets a reply. The advertise message, host responds to say, hey, I got it. DHCP server says I reply. And now we're up and running. So that happens. UDP port 546 and 547. Excuse me. Whew. Wow, I blanked out the screen there. That was a good sneeze. All right, so there we have it. Router advertisement says we're going to do DHCP v6. Host uses that method and comes up with the stuff from the DHCP server. It's going to give us configuration parameters, but, and this is why it's stateless, does not keep a list of those things. So upshot of doing this, I mean, I guess if you have other configuration parameters that warrant keeping an extra server sitting around online, sweet. And then here's an example of that happening. We send out the request, or the router advertisement hits the PC before it gets one. It has the A flag ticked and the O flag ticked. The PC says, okay, we need to talk to the DHCP server. It sends out the solicit message. It gets back some additional information from the DHCP server, and all is right with the world. I like how I have a router advertisement like going in my head. So you want to turn that on your favorite Cisco switch. Go in IPv6 ND other config flag. We'll set the O flag, the other flag, to 1. So here's our highlighted output. It says Hosts use stateless autoconfig for addresses. Hosts use DHCP to obtain other configuration, hence the O flag. Stateful configuration seems a little more worth your time. And notice M is set to 1 down here. Duck out of the way when we have to say that. So we get a router advertisement back that says, hey, use this DHCP server for all the configuration. So now if it's all, it's a stateful server. It's keeping a list of all the IP addresses, which means if you're an administrator and you're wondering what IP address did Bob's PC get, you can go and look at the list and say, oh, Bob's PC got blah, blah, blah. And all is right with the world. So that M flag is set to 1. O and A are set to 0. It says, I'm going to configure myself manually. So if you are setting this up on your favorite Cisco router, you go in IPv6 ND, managed config flag turns that M flag to 1. And when your clients see, if you do like a show IPv6 interface, you will see host use DHCP to obtain a routable address. Routable addresses are good. So if you're going to configure those, you've got a bunch of different players to keep track of. Your Cisco iOS router can be configured as a DHCP v6 server, and maybe shouldn't, and maybe should have like a real one, but a router can do the job. To do that, you have to go through and configure the following things. You have to, pick out the router that's going to do it. You have to, potentially, you can set up a router to accept a IP address from a DHCP v6 server. I am hesitant to let my DHCP servers configure my routers. Feels like bad mojo, but a thing you can do. And it can potentially be set up as a DHCP v6 relay agent, which means it's going to forward on various information, not just DHCP information, potentially others, to clients on the other side. So if you are going to configure a DHCP server for your on your router, break out your Cisco book and look up these commands. You will need to set up IPv6 unicast routing, which basically makes your router IPv6 aware, create a pool, IPv6 DHCP pool, and then give it a name, include perhaps a DNS server, perhaps a domain name in that configuration. Then say IPv6 DHCP server, pool in the name, and then if you want to goof around with your flags. And then verify after you boot up a client that it actually has an IPv6 address that looks like it's the kind of IPv6 address you configured. And you are off and running. If for some reason you want to make your router a DHCP client, seems like could get you into trouble, but similar set of steps. We enable the IPv6 unicast routing, basically making the device aware. You configured the client to create a LLLA, only 2 L's. So that link local address will come on using the IPv6 enable on that interface to bring it up. For whatever reason, Cisco loves that EUI64. You can configure the client to use Slack. IPv6 address autoconfig is Cisco for go ask for an address. And then you can show IPv6 interface brief to verify that that actually happened. You can show it for the individual interfaces to make sure that's in there. Make sure you got the DNS name, make sure you got the DHCP server or what have you. Mostly the same steps to configure that stateful server with a couple of changes. Again, enable IPv6, create your pool, go in and create the options. So the address prefix, the domain name, the DNS server IP address, maybe more, and then bind that interface to a pool by doing IPv6 DHCP server pool name on the interface in question, and then again with the changing the flags. Boot up a client, IPv ipconfig/all, make sure it's in there and you're off and running. A stateful DHCP server can also run a stateful DHCP client. Really, it's the same setup as before, just that you'll get a stateful address. So much the merrier. When you show IPv6 DHCP pool, it will return the name of the pool, the address prefix, the addresses in use, and then the other stuff you've put in there. If you show the bindings for your stateful routers, you will see the clients, their local address, link local address, and their GUAs, their global addresses, to let you know what's going on. That will be in your DHCP server. There are nicer DHCP v6 servers out there that you should probably be using, but this is why you would do that, because you want to be able to say, you know, where did Bob's computer wind up when it booted up? Oh, good. It's over there. If you have a nice DHCP server, really where routers do a lot of their heavy lifting is spending life as a DHCP v6 relay agent. So you've got this, you know, the big corporate DHCP server up there in corporate land somewhere. You would set up the remote clients routers as relay agents to relay the info back to that. That way the router kind of looks like the DHCP server to the clients. That doesn't really matter. And you can have that centralized client keeping track of, or centralized server, I should say, keeping track of all the addresses for the entire organization. So that tends to be how you see this sort of thing done. And then you can integrate that with whatever your authentication system is, and blah, 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 blah. But pick your relatively easy to set up, right? Pick your interface in question. And then if you're going to set it up as a relay, tell it where it is relaying to. So that's the 2001 DebataCAD 1.2. 2001 DebataCAD 1.2 is the network we're going to be talking to over gig 000. It's going to be relaying when this client asks for an address through that switch of this router. The router is going to relay the information back from that stateful DHCP server. And usually that's the way you see things going. So verify that. You should see show IPv6 DHCP interface should say, hey, this is in relay mode, and you will know that that's good. And then it will have some destinations that it is relaying. And then if you are taking a look at router 3, you can take a look at the bindings. Apparently that bad boy was set up to be doing this address. So it is in fact sending things out. On your Windows box, you can always just, you know, IPv6 or ipconfig/all and get the list of all the things. So, whew, that was a lot. This is a wall of text that reviews all of that. Let me out. I need to get better mime skills. So, routers have global unicast addresses, or GUAs. You can configure those with the IPv6 address, then prefix command. If you're doing that by DHCP, it figures itself out automatically. The link local address is booted up, or is created at boot time. Figuring out how you get that GUA address depends on how the router advertisement you see first is set up, and it will include one or more of the following flags: the automatic flag, the other flag, or the managed flag that tell you if you're dealing with a stateless, a stateful, or no DHCP server, in which case you will want to use Slack to configure yourself, which lets you create a default address. You can do Slack only, you can do Slack with DHCP, although why? IPv6 unicast routing will turn on IPv6, show IPv6, will verify that it is actually doing something. You can see the flags that way. Those router advertisements happen every 200 seconds. Totally seems like the kind of thing you'd ask questions about on a test. Slack usually gets its 64-bit subnet info from the router advertisement and then figures out its ID, hopefully using a randomly generated number or UI64. It is not maybe a complete waste of time to check to see if you have duplicated a 2 to the 64th power number, but hey, it's a thing you do. After we figure out if we're talking to a stateless or stateful router advertisement, we can go through and figure things out. If we're talking to a DHCP server, that's going to be UDP 48 on the server and, UDP 546 on the server, UDP 547 on the client. Stateless means it doesn't keep track. IPv6 ND other config flag turns on the O. ND managed turns the M flag to 1. You can set up routers to do that. You can set up routers as clients. If they're stateful, the router will keep track. Make sure you turn on unicast routing and you have a link local address. Show IPv6 DHCP pool and DHCP bindings will show you what's going on that server. And then you can verify if you're using a relay agent by showing the interface or by showing the bindings. That was a lot. Sorry, I just called like an allergy attack here too.